All right, so like I said, today we are going to look at pressure and its application. And what it's going to do is we're going to explain, say, why someone wearing snowshoes can walk across the top of the snow. It's all about pressure, and it's the same thing with the bed of nails trick, which really isn't a trick because it's actually when somebody sleeps on a bed of nails, that's easy compared to if there's just one nail sticking up. That would be a problem because of the pressure. Now here's what pressure is all about is pressure is defined as the amount of force applied per unit area and can be found using the following formula where P is pressure is equal to the force divided by the area. All right, so the units again are how much force per square meter. All our standard units that we've been using the whole quadmester still the same. Now, this is also called the Pascal. All right, so that's what I'll stick with is that 1 Newton per meter squared is 1 Pascal. And however, 1 Pascal is a very small amount of pressure, and therefore we commonly use kilopascals. So 1,000 pascals give you a kilopascal. You'll often see that with the weather. Well, the pressure will be measured in pascals, kilopascals. And what that is doing is actually measuring how much air is on top of you and the weather or how much the air weighs on top of us. That's kind of to do with weather, but won't get into that right now. So for instance here, little conversions. If we want to convert how many pascals is 88 kilopascals? Well, again, 1 kilopascal is 1,000 pascals. And so I would just take my 88 kilopascals, kPa, and well, we multiply it by 1,000. And because again, there is 1,000 pascals in 1 kilopascals, and so we would have 88,000 pascals. Oops, pascals, PA. All right, and going the other way. How many kilopascals is 102,000? Well, again, I can divide this time out because we're going the other way. So I take my 102,000 pascals. And again, I'm going to divide. I don't have that on my, little slash there. Divide by 1,000. And well, this time we would have 102 kilopascals. All right, so that's just bouncing back and forth, much like we've been bouncing back all year with between centimeters and meters and kilometers and meters and centimeters and meters and all those kind of conversions. Same thing with pascals, only you just have to know that there's 1,000 pascals in 1 kilopascal. All right, now we're going to use this formula. I'll get back to that. P equals F over A. That's what we're going to get into here now using. All right, so a box has a flat bottom, 2 meters wide by 3 meters long. If the box and its contents have a weight of 480 newtons, what pressure is the box exerting on the floor? All right, so first off, the box is rectangular and we have a length and a width. So I'm going to go with length is 2 meters, width is equal to 3 meters. All right, now the weight, what is that? That is telling us is that is the force that is applied on the floor. That's the force. So that's our 480 newtons. Now we want the pressure. And that's a question mark. We don't have that. Now looking at our formula here for pressure, we have P is equal to F over A. Now, what we don't have is the area, but we do have a length and a width here, and so I can find the area that the box covers, and that is going to be length times width, or in this case, 2 times 3, which equals 6 meters squared. All right, so now that I've got that information, I'll do a little bit of extra work here. I've got the force is 480 newtons. That's how much it weighs, or the force that's being applied to the floor. We're dividing by 6. All right, and if I take 480 and I divide it by 6, got my trusty calculator here, I get actually 80 pascals. Now, something to notice is that if you have 480, a weight of 480, and see how we're dividing by the area, and that's why the bed of nails trick, or I guess it's not even a trick really, works, is that if you have one nail, it covers such a very small area that if you weighed 480 and you divide it by the area of that one nail, well, the pressure would be extremely high, and well, that's probably why that nail will go right through you. But if you had a bunch of nails, a bed of nails, and they cover such a large area, then the pressure is so low because, again, the area is so high, even though the weight is the same. All right, so that's how that trick works. Again, it's not really a trick, it's just physics at its best. All right, example 4. Each of the 4 tires of a car, and the car has a mass of 1,400 kilograms, makes contact with the road over a rectangular area of 15 centimeters by 24 centimeters. Calculate the surface of each tire in contact with the road. All right, so again, we have a length and a width. So I'm going to have a length of, say, 15 centimeters. Now, again, here's a problem, is that's not in our standard units, which I've been talking about already today. And so I got to convert that to meters first. And so, again, there's 100 centimeters in it, so we got to divide by 100, so it's going to be 0.15 meters. Same idea here with the width, which is 24 centimeters. It doesn't matter which one's the width and the length, because you can just tilt them on their sides. But again, with that 24 centimeters, I'm going to divide by 100, and I get 0.24 meters. All right, so now, again, I can calculate the area. If I look at the contact of a tire on the road, it's just being a rectangular spot. And again, it's going to be length times width, which in this case is going to be 0.15 times my 0.24. All right, and now I multiply those two together. Let's see, probably going to get some kind of a decimal, I imagine. I am. I'm going to get 0.036. All right, now calculate. We get to B here. Calculate the magnitude of the force of the car on the road. Well, what we're talking about here is the weight of the car. And to find weight, which would be our force, it would be the force of gravity is the force that the car is pushing down on the road, which again is our value of m times g. All right, that's from our last couple units here. And again, the mass of this car is 1,400 kilograms, and again, times our 9.8. And so I calculate the force. This time we have to calculate both. It's going to be, let's see, I multiply those two, 13,720 newtons is the weight of the car. Now, calculate the pressure in kilopascals that each of the 4 tires exert on the road. All right, now first off, we know the area of every tire. All right, so let's put that down. The area of every tire is 0.036 meters squared. I should have thrown that in there before. Now the force of the car, we're looking at each of the 4 tires. So the tires, I'm going to say, distribute, or the weight is distributed evenly over the 4 tires. And so I'm going to take my force of the car, or the weight of the car, and I'm going to divide it by 4 because we're looking at each of the tires. Because again, I believe the weight is distributed even over the 4 tires, roughly. And so if I take 13,720 and I divide it by 4, I get 3,430 newtons. All right, and so again, that's because we got 4 tires. Pressure, that's what we're trying to figure out here. All right, so again, I'm going to use my pressure formula, where P is equal to F, the force over the area, Again, the way to increase pressure is increase the force or decrease the area, one or the other. And so now I have my 3,430 newtons of force on each tire. All right, over an area of 0.036. So if I'm dividing by a very small number, I should get a large amount of pressure. So let's see here. I take 3,430 and I divide it by 0.036. I end up with, whoa, yeah, I do get a big number, 95,000. Yeah, 95,277.78 pascals, which again, I could convert to kilopascals by dividing by 1,000, and it would be 95.28 kilopascals. And there we go. So that is all about pressure.